Mirror. Mirroring. I'm recording myself saying now. Hello, period zero. How are you? I'm sorry I missed you. Here we go. So period zero missed this part. So here we go. We have Adrian and Cormac are playing catch. Adrian throws the ball. They were excited. Adrian loved this last period, by the way. She was so mad. Hi, Adrian. Are you listening to the video? Hope you're liking this. Hey! Okay. Adrian throws the ball at an angle of 35 degrees relative to the ground at a speed of 22 meters per second. The ball travels 38 meters to Cormac, who catches the ball. How long was the ball in the air? So a couple things. Let's draw this out. Ready? I'm going to draw my launch ones like this, and I'm going to draw an angle like this. That's just my visual way of showing what I'm drawing. I know that the ball is leaving at 22 meters per second. That's great. And I'm going to draw my angle, my theta right here, and it says that it's 35 degrees relative to the ground. We also know that it travels 38 meters to Cormac, who catches it over here at this point. So we know that my change in x is equal to 38. Oh, I should make that a little bigger. I'm sorry. Is it hard for you guys to read, or just I'm old eyes? So facts that I know. What do I know? I know that my initial velocity is equal to 22. I know my theta is equal to 35 degrees. I know my change of x equals 38. I don't know my change in y. I also know I could say I know my a of y is still negative 9.8. I know how gravity works there. So those are the things I know, and it wants to know how long the ball was in the air, which is a change in time. How long is that ball in the air? I don't know, and that's what it wants me to solve. Okay, you good so far with what you have? It's always important to draw yourself a nice little sketch so you can see what's going on there. And then write down the terms that they give you so you can make sure that you're working with the right numbers. I like it as well because it helps me to come back to it later and see how did I solve that one? What did I do? Okay? So in this case here, for how long the ball was in the air for time, I have a couple options. I have this equation, which has a time in it, and I have this equation, which has a time in it, right? So if I want to solve for time, one of the things I could use, I'm going to go ahead and use the delta x. I'm going to use the delta x formula because I have a delta x. So I'm going to say delta x, change of x, equals the initial velocity times the cosine of the angle, all of that, times the change in time. I'm going to use that equation. So delta x is 38. My initial velocity was 22. My cosine of the angle is 35. And all of that is being multiplied by the t I'm looking for. So now with a calculator, or I could just, 22 times the cosine of 35 is equal to 18.0213, something like that, times t, which is still equal to 38. Now I'll divide both sides by 18.0213 to get the t by itself. And so 38 divided by 18.0213, in this case equals 2.108 seconds for t. Or if I just rounded that, I might say 2.1 seconds. So finding out how long it was in the air is a lot like the horizontal one. I just use a different equation, and I get to use cosine now. Okay? Is that okay? Notice that if I had given you the time, could you figure out how far it went? The distance traveled? What would I be looking for with distance traveled? The x, right? So if I gave you time and the angle and the velocity, you could find how far. So they're going to give you different parts of this, and you get to mix it around to figure out the part that's missing. You good so far? Savannah, you feeling caught up a little bit? Not too bad? A little bit bad, kind of bad. You gotta play with it a little bit. Let's look at the next one. It says Naomi kicks a soccer ball from ground level with an initial velocity of 15 meters per second at an angle 30 degrees to the ground. Use the vertical motion equation to determine the time spent in the air. This is the vertical motion equation to determine the time spent in the air. Keep in mind that the change in y is equal to 0 because it starts and ends on the ground. So, Naomi, here's Naomi, kicks a soccer ball from ground level with a velocity of 15 meters per second, and my angle is 30 degrees. I want to know the time. That's what I'm trying to figure out. I don't know how long it's in the air. But some things that I do know, once again, I know my initial velocity, which is 15. I know my angle, which is 30. Is that all I know? Yeah, that's all I know. Oh, I know my A, right? Negative 9.8. Do I know my change in X? Nope. Change in Y? Nope. So this formula comes in handy because I do know my change in Y. What is my change in Y? 0. Delta Y equals 0. So let's use this equation then and figure out what we got. We have 0 equals VI sine of theta, all of that, times t, plus 1/2 AY times t squared. So now we get to plug in some numbers. VI is 15, so 0 equals 15 times the sine of 30 times t, plus 1/2 times negative 9.8 times t squared. So I just have a bunch of weird numbers. That's what I got there. So 15 times the sine of 30 is going to be 0 equals 7.5 t. And that's going to be added to 1/2 times 9.8 is 4.9. Oh, I didn't need to make it a minus because that's a negative, so it's a minus 4.9 t squared. The next step you need to remember is to factor out the t. Take that t out of both parts, both variables. So 0 is going to be equal to t times 7.5 minus 4.9t, like so. And now my two options are here, t is going to equal 0, which is not true because we know it's in the air for a while, or 7.5 minus 4.9t equals 0. And now we solve for t. So t is going to be equal to negative 7.5 divided by negative 4.9. And my answer for t, this is a 2.1, no, wrong one, is 1.53 seconds. So it's a little bit of a long process for sure. I don't think it's a complicated process. It's just long. There's lots of little places where you might type the wrong number in your calculator more than anything else. Make sure you have the right starting equation here so you know where to begin from. And then remember to factor at this point so you can figure out what is your solution for t. Okay, can I move to the next one? Is that all right? Move to the next one, or one more before we go. The ball is launched at 4.5 meters per second at an angle of 66 degrees above the horizon. It starts and lands at the same distance from the ground. What are the maximum height above its launch? We have 1 minute. Oh my goodness, for maximum height. This is a tough one. Okay, so maximum. A couple things I know. For maximum, I want to first of all find the y component. I'll post this up for you guys later on too. The y component is going to be my velocity initially of the y, or yi, equals velocity initial times the sine of theta. So I have 4.5 times the sine of 66, which is equal to 4.11. Now, because we're talking about symmetry, this is my y initial is 4.11. That's my initial velocity to launch is 4.11 meters per second. but it means coming down, my ending velocity vertically is going to be the symmetry, the inverse of that, 4.11 meters per second. So that's my y component because of the symmetry related in the projectile. When it comes to the maximum, the equation you want to use is that your maximum is equal to negative v y initial squared divided by 2ay. So we would take our initial 4.11 squared, and we're going to divide that by negative 9.8. And when we do that, we end up with 0.86 meters. That's our maximum height of that projectile. So that's our maximum height. And then if we want to find the time, which is the second part of the question you'll be asked tonight, the time then becomes delta t equals our change in the vertical velocity of y divided by ay. So we're going to say minus 4.11 minus 4.11. This is our final minus our initial divided by negative 9.8. And that's going to give me 0.84 seconds. So those are the equations I use to find my time, my maximum, but I begin by finding the two y components here for my initial and my final to plug those in. So I'm recording this right now. I'm going to stop at that point. Your homework tonight is to do practice problems 4, A, B, and C, which are going to be just like the first one, and then 5, 7, and 10, which is a little bit like the second one, and you'll be okay. They're in your book. It's on yesterday's Google Classroom, same problems. Write them on your packet. We'll check them off tomorrow. Other than that, have a great day, and we will see you.